Hey all, how are you doing? So today's topic is all about operator overloading. Now this topic has a lot of importance in either polymorphic behavior or a modern neat coding. So let us get into the topic actually why we really need operator overloading, and without operator overloading what might it look like. So let me fire up Visual Studio. We create a new project, going for a console app, operator overloading demo, or just keep it simple, operator overloading. Next, I'm using .NET 9 as for now, and create this. Now what is really operator overloading? You know from your basic polymorphism concept that overloading means something that you want to reuse, right? You want to reuse. And the word polymorphism means many forms. So let me actually get into a very simple uh, like concepts. Let me get into Paint and give you an illustration. So you know the word overloading. I'm sorry, it's large font. Change it to small. 50. Overloading. Overloading means when you define something repeatedly. That is what is polymorphism is all about. That is, you define same thing in different way. Polymorphic. Poly means many, morphic means form. So operator overloading is a form of polymorphism. Just know this. Okay. So overloading means when you are trying to define same thing in different ways, like they're the same thing, the same word means something else. So what it does mean in context of operator overloading. So let me explain you. For example, if you have if you have an operator, the key word is operator. So what do you understand by operators? Plus is an operator, minus is an operator, this multiplication, call it star, is an operator, divisions are operators. There are a lot of operators in programming languages, like plus plus is an operator, minus minus is a decrement operator, right? You already know them, and they're mostly used in context of numbers. So plus, minus, multiplication, division, incrementation, decrementation, right? There are a lot more. There are a lot more. So these operators are primarily used in numerical context. All right. So that means you will use this plus in context of numerics. Like you can write 2 plus 2 plus 3, right? 2 plus 3. So you're going to be using this plus in the context of numerics, right? 2 plus 3. But you have already seen that we use this plus in another context. We might want to add like ABC, like ABC is a string, and then we'd like to add it to X, Y, Z, right? And finally, what we get is ABC XYZ, right? Or you can call it XYZ, ABC XYZ, right? So it's a join statement. You already know that. We call it concatenation, right? So this is a typical example of operator overloading with plus being overloaded. So this plus is overloaded in two different meanings. So the plus is overloaded. Overloaded means having two different meanings. So plus is used for doing some numeric calculation. Also, plus is used for concatenating two strings. Another example, well, another example. Let me first give you some examples so you'll understand. Well, like let's say you have a date time object. Date time, dt. Let me write a date time, which is, let's say, datetime dot now. All right. So that's the current date time. And let me pick up a time in the past, like maybe date time dt old equals to, let me pick up a date time. You know how to be creating a date time object. I can just write maybe 2020 0509. All right. So that's a time in the past. So 2020 that's the corona time. We all know that the world was reeling under corona. So this dt old. Now we'd like to know how far we have moved past this time. Now for that, what we do is var difference equals to dt, which is the current time, minus dt old, right? So what about this minus? Don't you think this minus has been overloaded? This minus is usually used for doing the subtraction on numerical values. But these are not numerical values in itself. They are datetime objects, right? Datetime is a structure and they are objects of datetime. So we are subtracting two datetime objects to create another object. Now, can you please tell me that what is the type of this object? So when you are subtracting two datetimes, you get another object. This object is known as time span object. So two datetimes subtract not to give you another datetime object, but to give you a totally a different kind of object. So if you hover the mouse, it just says the time span object. So I could have written time span directly, time span, right? Diff equals to dt current. I can also call it dt current. dt current minus dt old. The difference being the time span object, right? And we can then print this time span object in our own units. Now this is unit neutral, okay? This time span don't say that I will be in minutes or seconds or hours or days or years. This is a unit neutral object. So that means it's up to you how you want to look at it. So maybe I just want to get the time span differences in nanoseconds. You can do that, or sorry, in total nanoseconds or total seconds, or maybe total minutes or total hours, right? And total days. Maybe that I would like to know the difference in total days. That is the maximum value that you can get of the time span object. And if you want to get in years, you can divide by 365, right? So diff dot total days. Now I like to have a console.read key to stop the screen from going away. Read key. All right. So, by the way, I'm assuming that you have some decent understanding of object orientivity. You know what objects are, you know what polymorphism is. So, if you don't know, please go through some of my old videos. You can look at my channel. And if you really want to be having a one-to-one lecture with me, I'm most open for that. I take one-to-one lectures. I'm doing that for the past 20 years. And I've been teaching successfully all over the world. So in case if you want to take up a one-to-one course, you can definitely give me a tinkle. So now you can see this current minus old is the diff, and this diff dot total days is the total number of days. So that means this diff is being now expressed in total days. Let me run this and show you that this will exactly give you around 5 years or so. Little bit lesser than 5 years because I have this on the month of May. So 4 years and something will come up. Basically, it has come in days, okay? And now if you divide it by 365, this will give you in years, right? 4.9, right? Because as of this time of recording, today is 15th day of April 2025. So that is why we saw 4.9. All right. So now the point is that we have a datetime object, we have another datetime object, we subtracted one from another, we got another object. So that means subtracting one object from another or adding one object to another can produce totally a different object. This is absolutely fine. This is absolutely fine. However, adding to date time doesn't even make a sense. Think about it. Like if we add two dates, what do you really get? Think about it. Let's say if you have an if you are born in 23rd of July 1986, and let's say your sister was born 21st of September 1990. What it does mean by adding these two, right? It means nothing, right? It means nothing. You can subtract to get how old are you in terms of your sister, right? You can get how old are you uh, in context of your sister. You can definitely subtract the higher minus lower, right? But adding them don't make any sense at all. So if you try to do a plus, it will immediately flare up and it will give you an exception to say operator plus cannot be applied to operands of type datetime and datetime. So plus is not defined on date times, right? That's all I want to tell you. You cannot do plus on date time objects. This is not possible. That does that make sense? Hope so. So that means there are some operators which are only meaningful uh, if you do that particular operation, right? Not all operators will apply. So now that you understood that the meaning of operator overloading, so the operator overloading is nothing but reusing those numerical operators which we usually use for doing calculations in the number world, right? That is on integers, on doubles, on decimals. We can use them we can use them for other objects like datetime object, string object. Can we do it on money object? Or do we have a money class? No. So let's go and create a money class and illustrate the point. Now, for the money, we'll be having two parts, dollar and cents, right? You know that 100 cents makes a dollar, or maybe rupees and paisa. In India, we have rupees and paisa, the same concept. 100 paisa makes 1 rupee. Let's stick to dollar and cents, and let me create a class for that. Class money. All right. And this money class will be having two properties. So prop tab, I have already created the whole code for you. Yeah, I've already done that, but I just want to be creating. I don't want to copy and paste the whole thing. Just want to copy and paste step by step. So I just have two of them, money, dollar, and cents. So these are the two properties, dollar and cents. And then what we like to have? We like to be having a constructor which can deal with this. That's fine. So dollar and cents taken, and this dollar will be initializing the dollar property, and cents will be initializing the cents property. That's what we have. Now after that, we want to be calling a normalize function. Now what is really this? Why do you really have to be doing normalization? We'll just come to the answer very quick. So first let me copy this code. Let me copy and paste this here, and you understand that what does this really do. If you're a quick learner, you'll understand what I've done. Let me call my normalize function. Well, normalize means, let's say you have given cents larger than 100. So while initializing the money, okay, let me comment this code, okay, for initial demonstration. All right. So let me now create this money object. Create. So 5 comma 50. So $5.50. Now what if I write $5 and let's say 150 cents? That actually means $6.50, right? So we just want to make sure that the system doesn't just save it as 150 cents inside. Rather, the system should convert this 150 to 50 and take $1 and add to it. So that is the calculation. So I have this function. What I've all done is multiply dollar by 100 to get number of cents in the dollar and added the cents to it, okay, from these properties first, and then divide the cents by 100 to get the actual dollar and do the modulo division. This is the remainder division to get the cents, right? So just after capturing these dollar and cents into my variables, into my members, I like to fire this normalize so that they are normalized to the right values. They don't go wild, right? Hope that you got the point. So why this is so? So this is one money. Now we want to be having another money M2, right? Now all you want to do, let me have this a different money, maybe $9 and okay 20 cents. Let it be 70 cents, or fine. So $5.70 and $9.20. Now we want to be adding them up. Now for adding them up, what would you really do? We can create an add function and do that. Let me go ahead and do this. Like we can have oh, I know this is coming up. This GitHub is sensing too fast. I really don't want this good GitHub Copilot to work, but that's fine. So let me have a function. Oops. public money add money. Add money. The add money will be adding to money, and this is absolutely fine. So add money will take the other money and a new money object will be created with dollar as the first parameter of the first object, added with the other object's dollar, and cent of the current object will be added with the other object's cents. So this dollar belongs to the current object. So I should rightfully write this dot. This makes the code much more clear, and add it up with the other cents. So this is what is getting added to. And again we can write this dot cents getting added to other cents. So we are creating this new money object. The very moment we are creating this new money object, again a third money object is getting created. It is getting normalized as well, right? So we are normalizing it right at the moment of creation, and then that money object is being returned. If you are good in the basic object oriented programming, you will have no problem understanding this, right? So how do I now call this function? This is super simple. I can just write my money M3 equals to M1 dot add money. So M1 is the current money and adding money to the second object, and then whatever is getting added, we are getting the third money. We want to be having a display function, okay? So maybe I can write public void display. That's fine. So I accept that. So display will be displaying the money in the dollar dot cents, right? So that's the function dollar dot cents. So what all we're going to do right now here is we're going to be printing all of our three money. So M1 dot display, that's the first money. The second is M2 dot display, and this is the third money. So that means $5.70 added with $9.20 will be $14.90, right? So let's have a check how it works. Now, up until now, I have not used operator overloading at all. Okay, no operator overloading was used. The way we have done this is purely in functional approach. And let me tell you, Java people, Java language don't have an operator overloading. So Java guys use exactly this technique, right? So Java guys says that we want to be going in functional approach. So M1 dot add money. This looks like that you are trying to call a function on the first object, and then you'd like to pass in a parameter M2, and then whatever is passed in, you got your other object, the third object. Now this approach is just fine in Java terms. Okay. I mean, Java guys do that off and on, right? But we are doing C sharp, right? So C sharp has got the features of C++ also. There are a lot of good features of C++ what C sharp has taken. Among them is one of them is operator overloading. So let's see how does operator overloading helps to simplify the code. How it simplifies. I have also got a little text for you that what operator overloading will do. Operator overloading lets you to write more natural and intuitive code. Intuitive code. So what it is instead of writing this, what would be if we have written something like this? Think about it. Money M3 equals to M1 plus M2. Wouldn't this be great? So this is Java terms and this is C sharp terms. In C sharp, we can really do it something like that. This code is not so much readable, but this code is purely readable. M1 plus M2. This will be great, right? How great would it be if you can write money, let's say money M3 equals to, let's say money 1 is the first money, add $1 to it, right? So if you can add an usual number to a money object, I mean right now the object don't have those facilities. If I uncomment them, it is going to be showing errors all the way, right? It's not going to be showing anything good, but we can code our money class so that these guys really work. We can code our money class so that this guy can also work, like let's say m3 equals to m1, or we can just write like this. We just want to be increasing the money 1 by 1, money 1 plus plus. We just want to add one more dollar to money 1 to make it $6.70. Or maybe you want to take off $1, so m1 minus minus. Think about it. How cool would that be if we had a facility somehow inside the object, somehow within the class, so that these things can be done? Excuse me. Okay. These things can be done. So for these to work, we need to be implementing operator overloading within your class. So let's see how does they work. Let me comment it for now. Okay. So this works in Java terms. There is no problem in that. It's absolutely fine. We can still use them. So I like to convert this thing into something M1 plus M2. And look at this, how this can be done. Okay. And there is the code. IntelliSense is showing me, sensing me. So static money operator plus money M1 comma money M2. So this is how we write it. We start writing a static keyword. Mind, please notice this, that when we are trying to add to objects, we must start with a static keyword. All right. So all the operator overloaded functions, and we write them like operator plus or operator minus or operator plus plus or unary operators, plus plus and minus minus are unary operators. That is, they work directly on one operand, right? I hope that you know this point, that this is a binary operator. This has got two arguments. This has got two arguments. So this is a binary operator. However, this is an unary operator that just works on a single object, right? So we are in the process of creation of the, we have already done that. So this is basically operator plus, which has used the operator plus as a binary operator. It has got two arguments, money m1 and money m2. Now if you see, it looks like a function. That operator plus is a function. It takes in two arguments. Now the point is, when you call it like this, automatically this calls this function. Nobody would call this function. This function will be auto called. All right, this function will be auto called, passing in m1 as the first argument and m2 as the second argument. So you can think, if you write this, this will somehow change like this: m3 equals to operator, yeah, something like that. It will change to something like that: operator plus m1 and m2. So M1 and M2 are the parameters to operator plus, and this is producing my M3. But we will never write this, and in fact this will not work, right? So think about it. When we write this, this changes to this. I should have also written money M3. So money M3 equals to operator plus M1 comma M2. So when you write this, this internally changes something to like this, M1 comma M2. And the same thing for here too, right? So something which changes to something like that. Okay, so this guy will change to something like, one, as simple as this one, right? So operator, so we are just, this plus itself is overloaded here. Plus is overloaded in two contexts. First, the plus is overloaded in numeric context because plus has a usual numeric values for numbers. So we have given a different meaning for plus, and even within the class, this plus has got two different meaning. One deals with both money object, and second deals with one part as money object but second part as an integer. So let me go and write down that too, but before that please try to understand what we have done here. Money one is the first object. In the earlier case, the first object was the caller, was this, but in this case the first object is being passed to this particular function. So this m1 dot dollar, instead of this dot dollar we have m1 dot dollar plus m2 is here the other, so m2 dot dollar comma, so that comprises the first dollar. Dollars and dollars are getting added and cents are getting added. I've chosen this example. In the internet you'll find a lot of examples using complex number, right? But that's the subject of maths, right? So that's fine, but it's the subject of maths. But money is very natural. We all understand money, so it's easy for us to understand using money. So cents and cents getting added up, this can make it over 100. Please understand, if you've got 70 cents and 50 cents, that will add up to make like 120 cents. So it can be more than 100. That is the reason of having this normalized called. So they can add up, make more than 100. So definitely that call of normalization is indeed important. So we add up cents to cents, we add up dollar to dollar, we pass it to the new money object, and this new money object is getting created and getting returned. And this is what is the return of this operator plus. So notice this operator plus is returning the money object and taking in two money object. And how does it take two money object? It doesn't take it that way. We just call it this way. This automatically translates like this. This is the beauty and brilliance of C#. You do something inside, you do something from the top as a syntactic sugar, and internally things changes in its own beautiful way, right? So it's great. I hope that you understood it. Now let me uncomment this and show you this just worked. Let me comment this because I have two definition of M3s. So M1 and M2 got added up and we got my M3. If I run them now, this is absolutely fine. This works the same way, right? All the same way. This works the same way, right? Can you see this? Okay, I've enlarged the screen for you. So now what about this guy working? Let me have this money. Okay, let me comment this and just increase the money one by $1. Let me comment it for your convenience. Okay, so M1 plus 1. So you like to add $1 to it. So what can we do? This is very simple. We just copy and paste. The other parameter has to be an integer. Dollar, right? So you'd like to be adding dollar to the second part. So we have to be adding the dollar to the second part. So I mean the second the parameter is having the dollar, but we don't have any cents adding. We are adding dollar. So we are just adding dollar. We are not adding something like 1.5. No, we're not doing that way. We're just adding the number, just the integer, and we're adding and enhancing this money, increasing this money by so much money. I can do it anything. plus $5, right? So that will come here, that will come here, and will add up to this dollar part, and the cent part will be remaining unchanged. The cent part will just be the cent of the original money, M1, the money with which we're adding. So that creates the money. So in this way, we have overloaded the operator plus even within the class. So when we say operator overloading, we usually don't mean that we have got multiple definitions of that operator within the class. We just mean that the plus is usually a numeric context, has a numeric context. Now we have a different context, right? But now here it is truly overloaded. So that means even within the class, we have got two versions of plus, all right? What about if we have a minus? Yes, we can do that as well. So you can define a minus if you want to be taking out dollar. So the same thing, we just have to be writing a minus here. What about if you want to be having plus plus, that is unary operator? In this case, you don't have to be passing the second argument at all. So I will copy this and I'll paste this. So in this case, you don't have the second argument coming, right? Just only the first argument. So I can just write M instead of having M1. So in this case, all we will do is money plus plus is like adding $1 to the existing money, right? $1. So money one. So the new money will be M plus dollar plus one, and its cent part will remain the same. So I'll be writing plus plus here, right? So operator plus plus defined on money object, and what it is doing is it is just adding up $1 to the existing dollar object, to the current dollar object, all right, and doing nothing with the cents. Similarly, you can have a minus minus, right? So we have got minus minus. So simple and amazing. With all of them defined in right in the place, now we can go and check them. So money one added with 5, so this is already 5, adding 5, so that will be $10.70. So money one will be $10.70, money two will still show 9, and money three will be $10.70. Money one will be showing $5.70. So we can go ahead and run this. You can see it is showing as $10.70. I can increase the fonts possible. Yep, to make it bigger. Okay, so $5, $10.70. So I added up 5 to this, and I got this. This wasn't done anything. So you can clearly see how is it possible to leverage the power of operator overloading, a simple concept to add, subtract, divide, anything you want with objects. So if you want to be incrementing your, let me not write this now. If you want to be changing this money one by 1 unit and money two decrement by 1 unit, and you can really see the effect now coming up. So this will be $6.70, this will be $8.20. Let's go ahead and run this. Taking some time, probably got locked up. Let me run it again. There we go. There we go. So this is $6.70, and 9 subtracted by 1 is $8.20. So this plus plus and minus minus is really defined. So I hope that you got a good idea of what operator overloading is all about. Just like overloads means you can have same function with different arguments, we call it overloads, right? You got two overloads of the area function, that is one taking length and breadth and another taking just side to calculate the area of a square. You definitely come across these kind of examples. So you've got two overloads of the same function. So the same function has got two meanings depending on the parameters. Now in context of operator overloading, what we mean is we already have plus defined in the usual world, in the usual sense that pluses, minuses, they do the numerical calculations. But in context of this object, we are redefining it in different way. That is what is known as operator overloading. That is redefining the same numeric operator in our own way. However, this is quite possible that we can also redefine the pluses in two different contexts. That is, one taking objects, money objects in both the sides, another taking money object in the left side, but on the right side we are taking the integer object, right? So we can do in our own way. So that means here plus itself has been overloaded within the class as well, right? Same for the minus. We have also used plus plus. This is an unary operator. Unary operator overloading. And all of them are basically binary operator overloading. Binary operator overloading. So that is all about operator overloading. Let me a little bit take you through the to yeah to the text, that what it can do. Now I can really read this. Let me enlarge this a little bit. Yeah. So what it does, improves code readability. Operator overloading lets it write more natural and intuitive code. Like valid 1 plus valid 2, easy to read, isn't it? Money, valid 1 plus valid 2. Instead of writing valid 1 dot add valid 2, this is funny. Java guys do that all the time. This is the only reason I don't like Java so much. I will not say I hate Java. I learned Java as my first language even before C sharp. I started my learning with C and then C++ and then Java and then C sharp. But I don't like this kind of stuff with Java, you know. Anyway, so be it be whatever the language has. Java is a simple language, whereas C sharp is a very complex language having a lot of features. If you master C sharp, you have already mastered a very modern programming language. I can really tell you, if you master C sharp, you can easily do anything, any programming language, very easily. So invest more time learning C sharp anyway. So look at this. So this is so easy to write. Enables custom type to behave like primitives. So you are using plus, 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 minus, minus. They usually works on primitive types like integers, doubles, right? But you are using plus, 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 and minus, minus, or on a normal class type like a money type. So they behave like primitives, right? So the money, as we have done, vector, matrix, they all are that. Cleaner syntax in complex calculation. That's what I was telling you. That valid 1 dot add valid 2 dot valid 3. This is very complex. If you now come up with this example, you will be astonished to see one thing, that we can even do things like this. Wait a second, let me comment this. We can even do things like this, like money 4 equals to money 1 plus money 2 plus money 3. So you can keep on going this, plus money 1 plus money 2 plus money 3 plus $10 or plus $100. Think about it. How funny, isn't it? So that means we can, let me comment this, okay, and just directly print my money 4. So money 4 dot display, and look at this. So all this money will be added. First of all, these will be added to create the money tree using our Java terms. It depends on you how you write that, right? Let's say we are using this. We got this money tree, and then we are adding all of them and additionally adding 100. So you can clearly see, so it will be, 5 plus 9, 14. 14 plus 14, because it itself is already money 3, 28. 20 plus 100 is 128. So let's go and see if it comes. I missed the calculation, my bad. It's 129, little bit different. Okay, so that is what it is, right? I hope that you got the point. So what I mean to say is that you can go on doing this. So behind the scene, it first adds these two. Whatever is the object is adding. So that means, first of all, these two are added. It's a kind of chaining concept. And then with this, producing a money object, we are adding with M3. And then this even produces a money object. We are adding 100 to that. And all have been have been defined, right? All have been defined. If I have not defined this plus here, not defined the plus here, let me comment this, and you'll immediately see that this shows an error. This doesn't work. For this to work, we have to be having, see, it clearly says, isn't it? Operator plus cannot be applied on operands of type money and int because you haven't defined it. Whenever you see these kind of error, you know for sure that you have not defined some operator overloaded functions, okay, or function. So you have to be defining that function which says that I can add money with integer, money with integer, and commenting that, oops, will get this error out again, right? So this is what is being written. So cleaner syntax, instead of writing such a long functions, chaining function calls, we can just chain our operators, just like we do 5 plus 6 plus 10 plus 9, right? So that's the beauty. Consistency and reusability. Operator like double equal to can be defined so that logic, so that means you can also define double equal to, not equal to. They can also be can be overloaded. So not only you can define plus plus and minus minus, you can also define this. For example, you can define less than. Let me define one of them, less than. I want to check whether certain money is lesser than certain money or not. So let me define it real quick. So let me copy this and let paste this here, and I'm to be defining this less than guy. So what I'll do for doing that, well, for that I need to be having some concept. So I need to be getting the value of this. I'm sorry, this has to be money M2. Okay, so I want to check whether money M2 is smaller than money M3 or not. So very quickly I will convert this to cents, convert all to cents. I'm going to be comparing which cent is more. If this cent is lesser than this cent, we'll be returning a true, right? So what I'm going to do is that, like, int cents 1 equals to money 1 dot dollar times 100 plus what, money 1 plus cents, and the same thing. All right, so you understand this, right? It's very simple. And return if cents 1 is less than cents 2, but this guy will have to be returning a boolean because this is operator less, right? So am I doing some mistake? Let me see what I have done. Operator, oh, what it says is that now this is a companion. So if you have defined this, you must be also be defining the greater than. So both need to be defined. So if you have defined this less than, you super must define this greater than as well, right? So that means they will come in pair. If you have defined less than, you must also define greater than. You must provide the definition for greater than. This is all it says, right? So now you can really look at this, sense 1, sense 2, comparing if sense 1 is less than sense 2, returning true. Comparing if sense 1 is more than sense 2, we are returning true. So that means we can really do things like this. Like if this money 2 is greater than money 1, so we can print statement like money 1 is greater, right? And is money, sorry, the money 2 is greater, right? Indeed, money 2 is greater. It's $9 as against $5. So if you run it, it will really show money 2 is greater. Sometimes computer take more time. I don't know why. Let me cross and rerun this. Yep, money 2 is greater. Great. I hope that you got the point. So that means we can not only define plus minus, we can also define the logical operators as well. We can overload those logical operators. We can have double equal to, we can have not equal to, less than, greater than. That is wonderful. This helps in domain-specific classes like all financial apps, like we have defined money. For scientific computing like vectors and complex numbers. This is the example you see most of the time. And for gaming, like defining point object, position object, and also in the healthcare applications. So this is everywhere. Operator overloading is super cool. It's a syntactic sugar for C# developers, and this is really helpful. So Java developer will envy us, I can promise you. If some Java guys are watching, you know that you have to be going for such a long chain, right? So this is something to cherish, you C# developers, right? So that's what me, Shripto Kumar Mukherjee, signing out. If you really have any need for one-to-one classes with me, I can promise you, you'll learn the best. I'll take my whole time to teach you. We'll make sure that your concepts are crystal clear. Thank you and bye bye.